Hi, welcome to my channel. In this video I'd like to talk a bit about an electrical cables that I used in domestic installations. I'm gonna explain how to calculate the size of the cable for each circuit in the house, and also what fuse, what breaker to use to protect the cable. So that's the cable, thermostatic insulated flat cable for domestic installations in the UK. I don't know, in different countries maybe you've got different cables. Basically it's got 3 conductors in it, as you see: neutral, the blue one, line conductor, the brown one, and the bare one is the earthing conductor. So all the conductors have some resistance, there's some energy loss. So when the current flow to the conductor, they start warming up, and if you choose too small cable for the design current, obviously they can be overheated. So I've got here 3 cables, each different size. So this one is 6 millimeters, this one is 2.5 millimeters, and this one is 1.5 millimeters. And all the cables has got its own, depending on the size, its own rating. So this is called current carrying capacity. And for example, the thick one, the 6 millimeter cable, the current carrying capacity is 47 amps. We measure this in amps. The 2.5 is 27 amps, and the 1.5 is 20 amps. And how do I know all of this? From the book, The Electrician's Guide to the Building Regulations. But you can also find this on the internet, you have to just search a bit. So on the page 24 there is a table 2.3.1, and this explains everything. So this table gives us the rating of the cables. It depends obviously of the method of installation. So on this side, where the numbers are, you've got the here conductor cross-sectional area, basically the sizes of the conductors, the cables: 1.0, 1.5, 2.5, 4, 6, 10 and 16. So that's the sizes of the cables. Now on this side there's the installation reference method. So clip direct basically is when you clip the cable directly to the wall, and this is the rating for, let's say, 1 millimeter cable, 16 amp, 1.2, 1.5, 20 amp, 2.5, 27 amp, and so on. So the reference methods are few. So the rating of the cables I gave you is just for when they clip direct straight to the wall and don't touch any insulation. So let's see the reference method 103. This is surrounded by thermal insulation completely, so basically from every side. So now look at the cable, let's say 6 mil. When you clip direct to the wall, it's 47 amps the rating, but when you put it into insulation and wrap it completely, so the rating falls down to 23.5 amps. And the rest of the reference methods are just variation of the installation with insulation. So basically enclosing the conduit trunking on wall. Here is the in contact with plasterboard, covered by thermal insulation, not exceeding 100 mil, in a stud wall with thermal insulation, and so on, so on. So basically, when you clip direct the cable, the rating is very high. Any of the other methods with contact with the insulation, the rating goes down. So very useful book and very useful table. So now I'd like to show you how to calculate the cable size for the design circuit. So let's say we have a cooker. And the power of the cooker is 10 kilowatt. 10 kilowatt is 10,000 watts. Now to calculate the cable size we need amps, not watts, so we need to convert the watts into amps. So basically 10,000 watts you have to divide by the voltage, which is in UK 230 volts, and this gives us something about 43.47. So let's say 44 amps. That's our cooker. So now we need to choose the circuit breaker or fuse. I draw it like this. So let's say this is the circuit breaker. And this has to be at least equal or bigger than the cooker. So we can install 45 amp fuse or MCB. Now we need to calculate the cable. So let's say that's the cable. And this also, the rating of the cable has to be at least equal or bigger than the rating of the fuse. So how we calculate it? We need to use this book again. So we know how we install it. Let's say we clip direct to the wall. If we say that this has to be equal or bigger than 45 amps, so let's have a look at the first column. 47 amps bigger than 45, so that's the size of the cable, 6 millimeters. So then we know that this cable should be 6 millimeters minimum, as it's rated 47 amps. So if you use the same cable, you install it, for example, and this touching the insulation, so then obviously the rating goes down quite a bit, and then you have to use the 10 millimeter cable. So as you see, these numbers are just minimum. It's very close to the 44 amp that our cooker draw. So basically I would suggest anyway to install it on 10 mil cable, as nobody at home install it by clipping it to the wall. So basically 10 mil cable would be much better. So that's the very basic calculation, but there are some other factors that you need to consider when choosing the right cable for the circuit. So installation, the first one is the installation method. So that's what we was talking about, how you install the cable. So we've done this. Now the ambient temperature. So basically that's the surrounding temperature of the cable. Don't install the cable near boiler or near the radiator pipes, as they can be easily overheated. They cannot dissipate the heat when they're warming up. The grouping cables as well, number 3. So basically when you install, let's say 5 cables in a bunch somewhere in a wall, so they just warming up, they can't give the heat outside, as they just warming each other. So you need to consider this. And the voltage drop. So the voltage drop or voltage loss occurs in every circuit, and it just depends on the length of the cable that is on the circuit, and obviously from the items or bulbs that are connected to the circuit. So in here we've got the typical lighting circuit, consumer unit, let's say 5 rooms, 5 light fittings with a bulb. So at every point there's some voltage loss. At the beginning we've got 230 volts. So there's voltage loss in every, let's say, meter of the cable. So at the end it might appear that we've got the voltage only 220 volts. So in UK the allowable voltage drop for lighting circuits is 3%, and for the general power is a 5%. So you need to consider this as well when choosing the cable. Basically a too long cable can cause too much voltage loss, and then the bulbs will be flicking or the items not working properly at the end. So for lighting circuits at home you use 1.0 millimeter cable, but if you've got a large house and the one circuit serves few rooms, kitchen, few bathrooms and other stuff, so then I would consider to use 1.5 millimeter cable. This cable is a bit bigger and the voltage drop will be less. So there's a lot of things to consider when choosing the right cable for the circuit, but I'm gonna, to make life easier, I'm gonna give you a list of most common used cable size and circuit breakers for each circuit in a house. So that's the list I was talking about, and I'll leave it for a few minutes. Here we've got the circuits, the cable size, and the mini circuit breaker type B, which is most common used in UK.